In normal IoT scenarios, we are using consumer-based objects which are used in our day-to-day life, and we are connecting those sensors to the certain access point, and from there to the internet. In there, we are working with less complex sensors, which are related to the appliances that we use in our day-to-day lives. So we are, if we take, for example, a house, like a automated IoT or like home scenario, we can have our certain access point where we are taking our data, and we are connecting our data to the internet through fiber connections, and then through that we can actually access the internet, and then we can access anywhere we want through that. Okay, so we will be having connection to the internet, and from there we will be storing our data in some kind of a server, and then we can access some applications which is available in the cloud. So that's how we normally connect our systems. So if we take a smart home, we use doorbells, or alarm systems, lighting systems, or else like washing machine, refrigerators. So all these can be automated or monitored from a remote location by connecting those appliances to the internet. So in these smart home scenarios, the robustness of the sensors that we use is somewhat less, and we are using very simple sensors, simple and consumer-based, consumer-centric sensors we are using. However, in industrial scenarios, we are using more robust sensors, and we use kind of other processing techniques like PLCs. We can use PLCs, like programmable logic controllers, to process the data that are coming from the sensors. So have you learned about the PLCs in your classes, in control systems lectures? Do you have subjects related to PLC in your courses? All right. So actually, PLC is like a processing unit, which is like a rack, and it has inside it several components which are collecting data, which are connected to different sensors in the manufacturing facilities. So basically, we are using these PLCs in factories, in industries. So like you can view them if you visit industrial facilities. So if we have some kind of a sensor which we place in our production line, which will be like observing some product which is going in this production line. So let's assume these are like soap or something, and we can install some kind of a sensor at the edge of this production line to observe the production, or like the status of the products. So these sensors can be connected to the PLC using some wired connections, or maybe wireless connections. So we can connect to the PLCs, and the PLC is like the processing unit of the data in the industrial units, in the industrial facilities. So these PLCs are like large, like They are kind of large racks like things, like we have them in large shelves. So these programmable, sorry, programmable logic controllers. So you can do a lot of computations uh, inside these controllers. You can store the data, and we need to program this PLC according to our need. So based on our requirement, we can program it using certain programming languages. So we have, I think, a language for ladder. So we can control using programming languages. So we can code inside this PLC, and we can process the data we want. So the PLC will be like Arduino or ESP32 that we use. It's like that, but a more advanced version. So there are PLCs that are available in the industry, which has the combination of both Arduino and PLC. There are PLCs which are having the combination of the features of Arduino and the PLC. So we can program using Arduino language, the PLCs. So if you work in an industry, you might learn about these PLCs and how to program them. So in industry, basically, we have this connection between sensors and the PLCs. So after collecting data in the PLCs, the data will be stored in a central location in the industry. And after we collect that data in the central location, the industrial facility will do whatever necessary regarding the data in the local area, right? So, however, we need to improve the performance of the industry by connecting the industry into the internet, right? The data that we collect in the industry, by connecting that to the internet and by storing that in the cloud servers, we can monitor the status of the industry from a remote location, right? And we can do more computations if we upload the data to the cloud servers, and we do the cloud computing. And therefore, we the industries have implemented the feature of connectivity into the industries. So the industrial revolution, Industry 4.0, is the fourth revolution of industrial revolutions. And this revolution is having the connectivity feature, which allows the industries to connect to the internet and store the data in the cloud servers and do whatever the computations and get more performance out of the data that is collected in the industries. So because of this Industry 4.0 feature, or revolution, now the industries are able to connect with each other even though they are in remote locations or in different locations. And the industrial facilities itself can have more connectivity inside the facility. So if we take, for example, like if we have a PLC and if we have some sensors which are connected to the PLC, like a temperature sensor, so and some devices like some processing devices like a computer or something, and then we can have robots, so like some kind of a robot. So we can have different types of robots. I will take like a circular robot which is transporting items. So we can take robots, we can take sensors. So because of the Internet of Things concept and the connectivity concepts, now we are trying to propose systems that can talk to each other in the industry. So the sensors should communicate with each other, and sensors should communicate with other devices, and so on. So every component must be able to communicate with another component. So in order for us to do that, we need to install the necessary communication modules in each of these sensors and robots, such that the communication is done in the reliable or the most effective manner. So for example, if we use, let's say, Wi-Fi module, then we need to have the Wi-Fi module in all these equipments. So we need to have Wi-Fi module in here also to receive the signal that is sent through the Wi-Fi technology. So Wi-Fi uses certain frequency ranges, right? You know, it uses 2.4 gigahertz and 5 gigahertz ranges, right? So Wi-Fi module will connect or communicate through those frequencies only around that range. So the receiver must also be configured to receive in that frequency range, and in the whatever the other parameters that are defined for the communication. So there could be other parameters like what is the modulation scheme used, what is the multiple access scheme used. Likewise, there are different parameters that will that are defined for the Wi-Fi communication. So therefore, we need to have Wi-Fi. If we are using Wi-Fi module, Wi-Fi communication, we need to install, or we need to have Wi-Fi module available in all these equipments that want to communicate directly with each other. And therefore, we need to install these communication modules in all the components that are in the industry. So by doing that, we can enable connectivity between devices, right? So connectivity between devices can be established. So that is one of the targets of Industry 4.0. So the first one is connectivity between devices, and then connectivity between industries like infrastructure. So second thing is like connectivity between infrastructure. So that means like we can communicate between two infrastructures in different locations. So if we have one industrial facility in Colombo, there could be another industrial facility in, let's say, Hatton or something, right? So because of the connectivity feature, the PLC-based system can connect to a router, and the router will connect to another router, and likewise it can connect to the public internet through uh, through the connection to another router. So the internet is a collection. The internet is a collection of routers and switches, right? It's a wide network, very wide and complex network, and through the collection of the routers and switches, we need to select the optimal path to send our data, and through that optimal path, it will reach the destination router, and from there it will connect with the destination, the based PLC or processing unit. So by doing that, we can now connect with other industries, so other industrial facilities through the internet. So so the second aspect is connectivity between infrastructure, and third aspect is connectivity with I think like a remote, I mean the ability to monitor remotely. So third factor is remote monitoring. So we can monitor the status of the industry at a remote location. So a person who's connected to the internet through another access point can view the status of the industry uh, through that location, from that location. So they can access the industrial status through this method, and also they can also, we can also have a cloud server, which will uh, store all the data of these industries in a certain location. Like, let's say the cloud server is installed in here. So the cloud server is connected to this router, let's say. In that location, we can store all the data regarding the industries, and we can view that data from that cloud server. So anybody who want to access that data regarding these industries can directly access the cloud server and access the data. Also, the cloud server is able to do a lot of computations. So the industries do not have to do the computations. That can be done in the cloud. So if some kind of a harm is coming to the industries, and the industries get damaged or something like that, the data will still be available in the cloud server, if we have previously uploaded the data to the cloud server. So with that, we can increase the efficiency of the industries by adding cloud computing, edge computing, likewise computing technologies, and connectivity to the networks, right? So apart from that, uh, there are key features that are available in the industrial 4.0. So I will erase this section. So there are key features, key technologies. So if you do not understand, let me know. Right? Key technologies that enable industrial IoT. One of the key technologies is AI and ML. So AI is like artificial intelligence and machine learning. So machine learning. So ML refers to machine learning. So we need to integrate these technologies into the industrial scenario to improve the efficiency of the Internet of Things. So in artificial intelligence, we are actually building intelligent machines that um, that can respond to us like humans. So intelligent machines are developed that can respond as humans. So machine learning uh, is a subset of AI. So where the machines are learning using certain algorithm, and right, machines are based on algorithm, and this method is more accurate than other baseline methods, right? Than programming or programming based methods. So do you have questions regarding machine learning and AI? Do you know what it is? Are you learning machine learning? I mean, do you have course now? Are you doing something in your learning? Did you learn in the last semester? So did you learn? No, no, not a single module. You haven't covered anything. So it is one of the electives that you have, no? You can't select it. next semester, yeah. Mm. So you will learn about it. However, like machine learning is a very trending topic currently. So you can learn it on your own as well. So in the YouTube or in other sources in the internet, you can use ChatGPT, which is again a machine learning model. So you can learn about how to do machine learning on top of IoT systems, right, or any other systems. Like basically machine learning. Uh, there are many types of machine learning uh, that you can learn. So uh, I think you will learn about that later as well. So basically, there are like um, different models that you can use, that you can use to train a certain machine to do something using data, based on data, and make some predictions about the future, and do some useful work. So you will learn about that later as well. So then another key technology that is required for IoT is cybersecurity. So cybersecurity is like regarding security of the data and how we can communicate in a secure manner. Uh, Communicate in a secure manner. So we have different technologies that we can use to improve the security of our data. We can include technologies like blockchain technologies, and we can use encryption, decryption methods to secure the data further. And we can add privacy features also. Uh, so we can allow only certain people only to access uh, our data. So we can add some authentication techniques into our IoT networks and IoT systems. So by adding these kind of features, we can enable only the authenticated people to access the data. Right? Authentication means like you are given a certain username and password, and also given some other, let's say, like secondary authentication methods. Like Google is providing you authentication. So once you are accessing some kind of app or some kind of like a software, then you need to use your username password. But after using these features, you need to also give a certain code which is provided by Google authentication app, and then by that we can like improve the security of our login to our applications. So likewise, we can improve the authentication method to our data, and by doing that we can improve the security of our data and our data in the in the internet, in the social media and so on. So we need cyber security. Then we need to have cloud computing, uh, edge computing. So we learned about cloud computing and edge computing in the last class, in the last online class. So cloud computing means like the computing which is done at the cloud server, which is um, located in a remote location from the access from the place where we access the uh, access the network. Let's say like the IoT network is in somewhere in Sri Lanka. Let's say the access point is here. Uh, however, the cloud server is somewhere in US or some kind of a UK or some kind of a remote location, and the cloud server will be in a remote location, and it will do the computation in that location. So although cloud computing is good, sometimes we have to send the data over a large distance to reach the destination server. So destination server, if this is the destination server, if we do the collection of the data in Sri Lanka, for example, like if we collect the data in Sri Lanka, then we need to send that data through the internet to a cloud server in US, so somewhere in between, to do the computing sometimes. So in that case, the data transmission will be having a delay. So in that case, like rather than doing the computation in this destination cloud server, we can do the computations in a server which is installed at the access point of the IoT network. So we can install an edge server near the access point and connect that edge server to the access point, and we can do the computations in this server. So this server, which is connected to the access point, which is closest to the devices which are connected to the IoT network, the IoT devices. The server at the access point, which is closest to the IoT devices, will do the computation. So if that is done, we call that we do edge computing. So edge computing can be done in the servers, and we can improve the communication latency. We can reduce the latency of our communication. So that means, like, once I send some data, the data will be processed in this edge server. Right? Rather than sending the data through the internet to this cloud server, the data will be processed here. So the output of that data will be sent to us directly from the access point server to our devices. So which will be less latency, reduced latency. So we are actually still implementing this edge computing concept. Still, it is not in use, but research, it is done under research level. So we are trying to improve the computing done near the access point. The reason is that we want to improve the efficiency or reduce the latency and increase the real-time updates that we can get. Regarding our IoT and network. Okay, so we can get real-time updates. That means very quickly we can get updates regarding our condition in the network, right? So this is useful for scenarios where we are monitoring the environment. When we are monitoring the environment, we need to know, like, what is the condition of the environment. So the devices can get real-time updates from the access point based server very quickly once it is connected, once the data are collected by the edge server, and the edge server will give some data very quickly to the IoT devices. For example, if we are monitoring the temperature or the weather condition in the environment, then the edge server will update very quickly regarding that area of the environment, and the IoT devices can get information quickly. So that is the advantage of edge computing. So after that, we have fourth technology, which is data mining. So that is also related to like collection of data and processing data. So I will write that separately. I will remove these. Do you have any questions related to your IoT project or something as well? Did you submit? So in the next classes, I will also like grade your IoT project. I will ask you to come, and I will like I will check your project and give marks on in the class itself. So it's good if you can come to the class. I will discuss with you and I will finalize the mark to you. Data mining is collecting data from different elements of the IoT system and discovering meaningful patterns and knowledge. In data mining, we collect data, large amounts of data uh, from our sensors. So in industrial scenarios, we can take like we are collecting large amounts of data at the PLC from different sensors, and we are collecting those data in a frequent manner, right? We are collecting data frequently, and therefore the amount of data that is collected at the end of this, that is collected, for example, in the cloud server, which is connected to this IoT network, will be very high. Like big data will be collected here. And this big data will consist of different types of data from different parts of the IoT network, right? So if we take like different sensors, for example, this could be temperature sensor, another could be pressure sensor, another could be like videos or something from camera, like images. So different types of data are collected. So uh, the the goal of the technique of data mining is to uh, like get the useful like data out of these type of uh, um data types, and organize them in such a way that we can observe some pattern, like collect different types of data and organize those data and observe any kind of useful pattern, uh, observe useful information, uh, observe useful patterns in the data. And then using those patterns, we can actually predict the future outcomes of the IoT system, for example. So we can predict the future outcomes of the IoT network, IoT system. So based on the future outcomes, we can make decisions on what we need to do, right? So based on that, we can actually save money, save time. Likewise, there are a lot of advantages. Once we are using, we can save money and we can save time. So there are other advantages as well. So that is basically regarding the data mining. So we need to also we need to also use this technology in order to improve the IoT systems. So However, we have difficulty in implementing the industrial IoT systems with these technologies, right? So there are some difficulties that are there, right? So currently industries that are available currently are having only computer-based systems to trying to connect the whole industry infrastructure and the data collected in that industry to the internet. However, like the industries do not like to share their data. Their data are very confidential. So they don't want to share all their data. So they are still trying to like decide like what they can do in terms of uh, integrating Internet of Things into the industrial environment, right? So there are some challenges that comes with the implementation of industrial IoT. So once we are trying to implement industrial IoT, we have some challenges, right? We will face some challenges. So the cost of implementation is high, right? And then integration of data. Uh, so, uh, so the ability to like integrate large amounts of data integration is a challenge to the industrial facilities. So we need to enable like massive connectivity between our devices, and we need to connect our devices to the access point. So we need to build interfaces, communication interfaces, and we need to like we need to make sure that communication is happening very smoothly between the sensors and the access points. So we also need to do processing of those data. So this is not an easy task. So once we have large data, the processing of that data is kind of challenging, and therefore it still remains as a challenge to the industrial IoT networks. So we can actually solve these kind of problems by maybe splitting the data into different sections and then doing the processing. Also, if we want, so another challenge that we will have is having to integrate new hardware and software, right? Which increases the difficulty in implementation. Fourth thing is that the lack of expertise. So it is hard to find people who are expert in this. So people, training people and hiring people regarding these technologies is a challenge. So then cyber attacks will be available once we connect our access points to the internet, and once we upload our data to the internet, then our data is exposed to the internet if we do not send the data in a very secure manner. So if we do not send the data in a secure manner, a person who's accessing the internet will be able to access our data and even like do some damage to us. So in that case, like there will be threat, some like risk involved in sending the data through the internet, through the public internet to another location. So another like so once we are sending data across the internet, a person who's accessing the internet can hack this. I mean, can connect one of the routers and then can hack our data. So a person who's intruding can get the data and then try to do something uh, like damaging to our industrial scenario, for example. So therefore, cyber attacks is also a challenge in the industrial IoT scenarios. So do you have any questions so far regarding industrial IoT scenarios? Have you gone to industrial training? You're going to go in the next year. This year you don't have any training. You're in the second year, third year. You don't have any training in your third year. Only in the fourth year you have all the training, all the training. Yeah, seventh batch is having next month. Yeah. Okay. So there are companies who are already having companies who are already embracing the technologies of industrial IoT. So already some companies in mostly developed countries have implemented industrial IoT technology. So some of those companies are like General Electric company. So this company we call as GE. So think like this, GE, and this company is using industrial IoT in their industry. So they are actually building motors like engines that are required for aviation, healthcare, and so on. So the production facilities, they're trying to optimize using industrial IoTs. So they are building like motors, engines that are required for aviation and healthcare, so on. So these companies are trying to embrace the Internet of Things, industrial IoT, to improve the communication of the data from one location to another location in their like companies, and then in their industrial facilities, and also store the data in cloud servers and so on. So they will be doing the processing in the cloud servers and making some useful outputs using technologies like ML and so on. So that is one example where they are using industrial IoT technologies. Also, Siemens. Siemens is another company which is using that technology. So most of these companies are available in, I think, in USA. So, however, like those companies are trying to improve their systems using IoT. So John Deere is another company which is using some IoT systems for agricultural equipment manufacturing. And right. So likewise, there are so many examples that shows us that industrial IoT is actually available in the real world. This is not a virtual idea. This is already implemented in some companies in the world that have enough money to implement this. Okay, so you can search about this, search about more industrial IoT based company, IoT based IoT technology, companies that incorporate industrial IoT technology. So search about the companies that integrate industrial IoT technology. So that is all I have for today. So you can search about industrial IoT, and you can search about industrial 4.0, right? So in today's class, we talked about industrial 4.0 revolution, and we talked how in there they want to improve the connectivity in the industries, and we can improve the connectivity by enabling the communication medium between the devices, and the sensors, right? And then we can connect that to the internet, and we can do the computations in the cloud. So by integrating these technologies, basically, we can implement an industrial IoT system, and we can add some technologies such as machine learning, cyber security, to improve the security and the uh, usefulness of the data that we upload to the cloud servers. Right, so we can improve using these technologies of the IoT network. So that is all I discussed about in today's class. So if you have any questions, you can ask. Otherwise, I will end today's class now. So do you have any questions? Do you want questions?